Hello, and welcome, dear dreamer, to Boring Science for Sleep. It's always a quiet joy to know you've returned, settling in here beneath the blanket of night, where the distant universe becomes our bedtime companion. Whether you're lying down after a long day or drifting in the still hours before dawn, this space is yours to rest, to wonder, and to let go. Most stars in the sky behave like faithful beacons. They shine with steady light, unblinking, unchanged across centuries. But every so often, one behaves differently, like a candle in the wind, its flame faltering when no wind is there. This is the story of such a star that puzzled astronomers not because it was faint, but because it kept slipping in and out of brightness in ways that defied explanation. A star tucked within the Cygnus constellation, known in the catalogues as KIC 84628552, but more often whispered about as Tabby's star. The dips in its light were astonishing. Not a gentle blink, not a predictable rhythm like an orbiting planet would cause, but sudden, deep plunges, sometimes by as much as a fifth of its brightness, as though something vast had swept across its face. And then, just as quickly, the light returned, steady once more, until the next unexplained dimming. At first, astronomers thought it might be swarms of comets, or veils of dust, or perhaps even fragments of broken worlds drifting past. But the star's behavior refused to settle neatly into any of these boxes. And so, whispers grew bolder. Could it be something we had never seen before? Something built, not born? Tabby's star invited not only science but imagination. It became a reminder that, even with all our instruments, all our data, the cosmos still holds riddles. And sometimes, those riddles flicker right in front of us, visible to anyone willing to watch the stars. Tonight, we'll wander through this mystery gently. We'll follow the trail from the first puzzling light curves, through the wild theories, to the quiet truths that linger. So let your body grow heavy, your mind drift light, and your thoughts follow the faint, flickering glow of a distant star that refuses to explain itself. In the early years of the 21st century, a telescope drifted silently in space, its gaze fixed not on a single star, but on thousands. Its name was Kepler, and its mission was deceptively simple: watch stars carefully, patiently, continuously, to see if any of them flickered just enough to betray the presence of a planet. The method was straightforward in principle. When a planet passes in front of its star, it blocks a tiny fraction of the light, producing a dip in brightness, a transit. By measuring those dips, astronomers could discover worlds orbiting faraway suns. It was a task requiring persistence, and machines are good at persistence. Kepler stared for years, measuring every photon it could catch, building light curves, long graphs of brightness over time, like heartbeats traced in starlight. Most of these light curves told ordinary stories: gentle, repeating dips, planets circling again and again, predictable as clockwork. Some showed multiple planets, their transits overlapping in a graceful dance. Others showed stellar flares, or the quiet variability of stars themselves. But amid all this rhythm and repetition, one star broke the pattern. It lay in the constellation of Cygnus, about 1,500 light-years away, and it looked unremarkable at first. A star, not so different from our Sunday. In the catalogues it bore the cumbersome designation KIC 8462852, but in its light curve, something extraordinary lurked. Instead of neat, periodic dips, its brightness plunged erratically. Sometimes it dimmed by a fraction of a percent, sometimes by 10, even 20%. The dips were deep, irregular, and unlike anything Kepler had recorded before. No planet, not even a giant, could block so much light so suddenly, and the dimmings did not repeat in cycles as planets do. They seemed random, unpredictable, as though the star were playing a game of hide-and-seek with the universe. For the astronomers combing through Kepler's data, it was at first a curiosity, then a puzzle, and finally a mystery. What could cause such strange, irregular flickers? A planet was too small, too consistent. A binary companion star might explain long-term changes, but not such sudden plunges. It was as though vast clouds or structures, irregular and immense, had passed across the star, blotting out its light in clumps and swarms. At first, the data seemed almost too strange to believe. Could it be an error? A flaw in the telescope's sensors? But checks and rechecks confirmed it. The dips were real. This star was truly behaving in a way no one had seen before. When astronomer Tabby and her team examined the light curve in detail, the strangeness deepened. One event in particular, nicknamed the Day 800 dip, showed the star dimming by nearly 15% for several days. Later, even deeper dimmings occurred, reaching nearly 20%. To put this in perspective, if Jupiter passed in front of our Sun, it would block only about 1% of the light. Whatever was passing in front of Tabby's star was not a planet. It was something far larger, or far more complex. The light curve looked less like the heartbeat of a star with planets, and more like a piece of modern art. Jagged drops, uneven intervals, no clear rhythm. It was unsettling in its irregularity, as if nature itself were misbehaving. For the team, the first reaction was not to leap to extraordinary conclusions, but to search for ordinary explanations. Could the telescope have caught a swarm of comets? A collision of moons or planets that released great plumes of dust? Could there be some internal stellar process dimming the light? Each possibility was considered, but none seemed to fit all the details. And so, the mystery grew. It is important to remember how unusual this was. Astronomers are used to anomalies, but usually, those anomalies yield to explanation after a little work. Stars pulse, dust drifts, planets transit. The universe has rules, and though they are sometimes complex, they are not capricious. But here, the rules seem to falter. Tabby's star refused to give up its secret. Imagine for a moment being among those first researchers, staring at the graph on your screen. For years, you have looked at light curves that behave, neat dips that repeat, whispers of planets that circle faithfully. And then, this, a star that dims not by a fraction of a percent, but by a fifth of its light, at times unpredictable, with no cycle, no order. The feeling would be both thrilling and unsettling, like walking into a familiar room and finding the furniture rearranged by unseen hands. For the public, the strangeness of Tabby's star soon became irresistible. The idea of a star blinking without explanation was too mysterious to ignore. News outlets began to pick up the story. Speculation grew. Some clung to natural explanations, others wandered into wilder imaginings. But at the heart of it all was the simple, undeniable fact. The light curve was real, and it did not match anything we knew. And that, perhaps, is the essence of wonder, not in what we can explain, but in what resists explanation. Tabby's star became a symbol of the unknown, a reminder that even with advanced telescopes and oceans of data, the cosmos still has ways to surprise us. For you, lying here tonight, perhaps with eyes half closed, let that thought comfort you. The universe is vast, and though much of it follows predictable patterns, there are still stars that flicker in ways we cannot explain. There are still mysteries that lie waiting in the data, puzzles that remind us we are not yet finished with discovery. So imagine that light curve now, traced as a line on a graph, steady brightness, then a sudden, sharp drop, like a heartbeat stuttering. Imagine the star itself, 1,500 light-years away, shining faithfully for millions of years, and yet, in our brief watch, dipping and dimming as though playing tricks. What passed before it? Dust? Ice? Broken fragments of worlds? Or something else? Something beyond? The question remains, and in the asking, wonder is renewed. But a light curve is only a graph, only numbers on a screen. To understand the story, we must also understand the people behind it. For this strange star might have remained a curiosity, if not for the astronomer who championed it, who asked the questions and gave the star its name. In the next part of our journey, we'll meet Tabby, the scientist whose persistence brought this mystery to the world, and whose name the star now carries. Behind every strange light curve, behind every puzzling graph that flickers across a computer screen, there is a human being who notices. Someone whose eyes linger just a little longer, whose curiosity resists the urge to move on. For Tabby's star, that person was Tabby, an astronomer with a steady gaze and a patient heart. Tabby, known to her colleagues and students simply as Tabby, was part of a generation of scientists raised in the age of space telescopes. Where earlier astronomers spent long nights at the eyepiece, she worked with vast datasets streamed from Kepler, numbers flowing like rivers of starlight across digital screens. Kepler had been staring at thousands of stars at once, watching for planetary transits, and its treasure was not in single photographs but in years-long sequences of brightness measurements. It would have been easy to overlook anomalies. The data was immense, the patterns repetitive, the stars mostly obedient to their natural rhythms. But Tabby did not overlook. When her attention turned to KIC 8462852, she noticed its erratic behavior and felt the weight of something different. She was not alone. Around her, a network of citizen scientists, volunteers participating in the Planet Hunters project, had flagged the star as unusual. They scrolled through Kepler's endless graphs, searching for the telltale dips of planets, and instead stumbled across something stranger. These citizen observers passed their curiosity along, and Tabby, with her training and focus, took the mystery seriously. Imagine her at her desk, late evening perhaps, coffee cooling beside her, the light curve glowing on her screen. The star's brightness drops abruptly, then steadies, then plunges again days later. The pattern is irregular, deep, unsettling. Most stars are like clocks. This one was like a candle guttering in invisible wind. She began to share the data, to discuss it with colleagues, to write. What emerged was not just a technical paper, but a story that rippled outward. In 2015, her team published an analysis that highlighted the strange dimming of KIC 8462852. They catalogued the dips, explored possible explanations, and admitted freely that no simple model fit the data. This openness, the willingness to say we don't know, is what gave the star its life in the public imagination. For science is often portrayed as a machine of certainty, yet here was a scientist saying, with honesty, that the light defied understanding. The humility of that admission made space for wonder, and because she had carried the mystery into the light, the community gave the star her name. It became Tabby's star. Not the catalogue number, KIC 8462852, cold and impersonal, but a name tied to a person, a story, a human connection. Every time the star is spoken of now, it carries with it her legacy, a reminder that science is not only about data, but about people willing to care for that data, to notice when something unusual stirs. For Tabby, this was not a path to easy answers. It was the beginning of years of investigation, debates, and speculations. She became the face of the mystery, fielding questions from reporters, speaking at conferences, raising funds to continue observations. In interviews, she remained steady, emphasizing the search for natural explanations, even while acknowledging the allure of wilder ideas. She embodied the delicate balance of science, open enough to wonder, grounded enough to resist leaping too far. And what a role to find oneself in, to be the namesake of the most mysterious star of the decade, to have your curiosity mirrored by the world. It was not only a scientific challenge, but a human experience. Tabby's star became a story that belonged both to the Academy and to the public, bridging the quiet rigor of data analysis with the restless imagination of those who read about it in headlines. If you close your eyes, you can picture her in that role, standing before a room of colleagues, projecting the light curve, pointing to the plunges of brightness, saying, "Here is something strange." Sitting at her desk, answering emails from citizen scientists who want to know more, speaking softly in interviews, her voice calm, explaining the possibilities and the limits of our understanding. She became the caretaker of a mystery, and in doing so, reminded us all of the humility and persistence that science requires. There is something deeply soothing in that thought, that science is not only about grand revelations but about gentle patience, about people like Tabby willing to hold questions without answers, to nurture mysteries until time and data yield clarity. For you, dear listener, perhaps resting in the quiet now, let this remind you that not all riddles are meant to be solved immediately. Some are meant to be held, like fragile lanterns, glowing softly, lighting the way without revealing the whole path. Tabby's star was such a lantern, and Tabby herself carried it for us. Her story also shows how science is both individual and collective. Without the sharp eyes of volunteers, the star might have been overlooked. Without Tabby's focus, it might have remained a curiosity rather than a puzzle worthy of study. Together, they made it into a story that reached the world. And in that story, there is comfort, because it tells us that the universe still has the power to surprise, that even with powerful telescopes and endless graphs, we are not finished discovering, and that sometimes those discoveries arrive not in grand explosions, but in faint flickers, patiently noticed by those who care enough to look. As you drift deeper into rest, think of Tabby's star not only as a mystery of astronomy, but as a reminder of human curiosity. A star dimmed, a scientist noticed, and the world wondered. It is a gentle chain of events, stretching from distant light years to your own quiet thoughts tonight. But what, then, could cause such dimming? If not a planet, then what? In the next part of our journey, we'll step into that question, the first attempts to explain Tabby's star and why the ordinary answers, so reliable elsewhere, seem to fall short here. Astronomy, like much of science, is often a game of patterns. When something unusual is seen in the sky, the first step is not to dream wildly, but to compare it to the things we already know. A dip in starlight? We've seen that before. It's usually a planet. A flare of brightness? Likely a stellar outburst. A periodic curve? A companion star. The universe has rhythms, and astronomers have learned to recognize their signatures. So when Kepler revealed the strange flickers of Tabby's star, the natural instinct was to ask, could this simply be a planet passing in front? But almost immediately the answer was no. A planet's transit blocks only a tiny portion of its star's light, at most a few percent. Jupiter, the giant of our solar system, would dim the sun by less than 1% if viewed from afar. Yet Tabby's star dimmed by 15, sometimes even 20%. That would require something enormous, something far larger than any planet we know, larger even than a star itself. Planets do not cast shadows so deep. And there was another problem. Planetary transits are predictable. They recur with clockwork regularity, each orbit producing the same dip, again and again. But Tabby's star did not obey a rhythm. Its dips were erratic, uneven, sometimes shallow, sometimes deep, spaced at intervals with no discernible pattern. If it were a planet, it would be a planet unlike any ever seen, behaving in ways that defied orbital mechanics. So the planet explanation fell away. Perhaps, then, it was not a planet, but a companion star. Many stars are part of binaries or trinaries, dancing in gravitational pairs. A smaller star, passing in front of a larger one, can cause deep dimming. But companion stars, too, have cycles, and their eclipses repeat in steady intervals. Tabby's star showed no such rhythm. Its flickers were irregular, as though the star were winking at us with no rhyme or reason. Next came the thought of dust. Dust is the universe's quiet sculptor. It drifts in clouds, it scatters starlight, it can obscure and reveal. Perhaps a vast cloud of dust was drifting between us and the star, blocking its light in uneven sheets. At first glance, this seemed promising. Dust can behave irregularly, breaking into clumps, shifting with unseen currents. But the trouble with dust is that it leaves a signature. Different wavelengths of light are dimmed by different amounts, producing color shifts we can detect. Tabby's star dimmed across all wavelengths nearly evenly, as though something opaque and large were at play, not fine grains of cosmic powder. What about a swarm of comets? This theory gained traction early. Imagine dozens, even hundreds of icy bodies swept into elongated orbits, their tails overlapping, producing temporary veils across the star. This could explain irregular dips, since comets travel in swarms, their dust spreading unevenly. But the scale was daunting. To produce a 20% dip in brightness, the swarm would have to be unimaginably dense and vast, something never observed elsewhere. And again, the spectral evidence was weak. The data did not match the fingerprints of icy dust clouds alone. Others proposed collisions. Perhaps two planets had smashed together, sending up plumes of debris that temporarily darkened the star. This could, in theory, explain a sudden deep dip, as fragments passed across the stellar face. But such events are rare, catastrophic, and the debris would eventually spread into a disk that produced more predictable patterns. Tabby's star, by contrast, continued its irregular blinking, as though no single event could account for its behavior. Piece by piece, the usual suspects were considered and dismissed. A planet too small, a binary too regular, dust too selective, comets too improbable, collisions too brief. Each explanation solved one part of the puzzle, but left the rest unsatisfied. This is where the mystery deepened, for astronomers are used to the universe behaving in familiar ways. When data resists those ways, it pushes us into discomfort. What, then, could explain a star that dims so deeply, so erratically, without leaving the expected fingerprints? For the scientists working with Tabby's star, it became a practice in humility. They were forced to admit none of the normal explanations fit. This was not a planet, not a binary, not the kind of dust we know. Something else was happening. And here is where the wonder begins, because it is in these moments, when the usual answers fall short, that our imagination awakens. For centuries, humanity has looked at the sky and asked not only what is there, but what if? Tabby's star was a stage for that question, a reminder that the cosmos can still defy our categories, still present us with riddles too large for tidy solutions. Imagine lying back now, eyes closed, picturing that star. To the naked eye, it is just another point of light in the Cygnus constellation, indistinguishable from its neighbours. But hidden in its glow is a drama invisible to us except through patient instruments, a light that falters unpredictably, as though something vast drifts across it. You feel the comfort of routine fade, replaced by the shiver of mystery. And yet, let that mystery soothe you, for it tells us that we have not reached the end of discovery. Even as we map galaxies and count exoplanets, the universe still hides surprises. Tabby's star is proof that there are still puzzles in plain sight, waiting to remind us of our limits and our wonder. But science is never content to stop at mystery. If the normal explanations failed, new ones had to be imagined. And so, astronomers turned to bolder possibilities. Swarms of comets, seas of dust, even worlds breaking apart. In the next part of our journey, we will drift through those theories, the attempts to explain Tabby's star with natural causes, each more imaginative than the last. When a mystery lingers in the night sky, the first instinct of scientists is to turn to nature for answers. Before imagination drifts into the extraordinary, we look to the ordinary: dust, comets, collisions, the quiet processes that shape the cosmos. And so, when Tabby's star dimmed in ways that seemed impossible, astronomers began to weave together natural theories that might account for its flickers. Dust was the first suspect. Dust is everywhere in the universe, often unseen until it drifts into starlight. It softens the glow of galaxies, reddens the colours of distant suns, and paints nebulae in veils of shadow. Could it be that a great cloud of dust passed between us and Tabby's star, blotting its light in irregular ways? At first, the idea was promising. Dust can clump and scatter, forming shifting screens that block a star unevenly. It is unpredictable, dynamic, fragile. And yet, dust carries a telltale signature. It dims some colours of light more than others. When astronomers split the star's light into its spectrum, they found that the dips did not behave quite as dust should. The dimming was almost equal across colours, suggesting that if dust was involved, it had to be of a very unusual kind, perhaps larger grains, perhaps an exotic distribution, unlike those we typically see. Still, dust lingered as a candidate, for it had the right spirit, subtle, shifting, capable of explaining irregularity. Later studies even suggested that at least some dust was present, but it could not explain everything. It did not account for the depth of the dips, or the long-term fading that Tabby's star also displayed over years. Dust alone was too thin a veil to cover so vast a light. The next possibility was comets. Imagine a family of comets, perhaps dozens, perhaps hundreds, all swept into eccentric orbits that brought them across the face of the star. Each one, with its nucleus and its trailing tail of ice and dust, could dim the light slightly. Together, overlapping, they could produce dramatic dips. Their irregular spacing might explain the lack of rhythm in the light curve. It was a theory with poetry. Comets are ancient wanderers, fragile and luminous, capable of veiling a star in fleeting ways. Perhaps Tabby's star was experiencing a great storm of comets, a celestial migration unlike any we had seen before. But the scale was daunting. To dim the star by nearly 20% would require not just a handful of comets, but a swarm of staggering size. So many icy bodies, so dense and overlapping, that their combined shadows stretched across immense distances. It seemed implausible that such a swarm could exist without leaving behind other evidence, or without having been seen elsewhere in the galaxy. The comet storm was possible, but stretched credibility. Then came the idea of broken worlds. In the chaos of planetary systems, collisions are not rare. We know from our own history that Earth was once struck by a Mars-sized body, Theia, an impact that gave birth to the Moon. Could something similar have happened around Tabby's star? Perhaps two planets or moons collided, shattering into fragments, releasing clouds of dust and debris. Such fragments could drift across the star, producing deep, irregular dips. This theory carried a haunting beauty. Imagine a planet breaking apart, its pieces orbiting in chaotic swarms, casting shadows as they pass. For a moment in cosmic time, the light of the star would flicker erratically, until the fragments either spiraled inward or dispersed into space. The idea explained both the depth of the dimmings and their irregularity. But here, too, the details resisted. A collision should produce heat, infrared glow detectable by our instruments, as dust and debris radiate their stored energy. Yet no such glow was seen. Tabby's star remained stubbornly quiet, dimming without warmth, as though hiding its secrets in silence. And so the natural theories circled, each one offering a piece but not the whole. Dust explained irregularity but not depth. Comets explained unpredictability but demanded impossible numbers. Collisions explained drama but lacked the expected signatures. None fit perfectly, yet all hovered near possibility, like fragments of a puzzle missing their center. For astronomers, this was both frustrating and exhilarating. Science thrives in puzzles, and Tabby's star was a puzzle of the purest kind. Every natural explanation fell short, yet none could be dismissed entirely. It was as though the universe were offering a riddle written half in shadow, daring us to guess the missing lines. For you, resting tonight, perhaps the details are less important than the feeling. Imagine a star far away, dimming and brightening unpredictably, while astronomers on Earth propose dust clouds, comet swarms, broken worlds. Each idea is like a story, a way to give shape to the flickers. None of them may be final, but each is a reminder that we are still learning, still stretching our imagination to meet the sky. There is comfort in this uncertainty. It shows us that science is not a finished book, but a living conversation, that even the most ordinary-seeming star can surprise us. That mystery is not a flaw, but a feature of the cosmos. Perhaps the truth of Tabby's star is dust, in some unusual form. Perhaps it is comets, or fragments of shattered planets. Perhaps it is a mixture of all three. Whatever the cause, the mystery has already done its work. It has reminded us to look carefully, to question, to wonder. And wonder, after all, is what keeps us gazing upward. But when the ordinary explanations faltered, the imagination of the world leapt further. Dust and comets might explain some things, but could they explain it all? In the next part of our journey, we'll step into the boldest idea of all, the one that captured headlines and imaginations alike, the possibility of alien megastructures. When science reaches the edge of explanation, imagination often leaps into the void. Astronomers are trained to be cautious, to search first for dust, for comets, for broken worlds. But the public imagination is not bound by such caution. And so, when Tabby's star refused to fit neatly into familiar categories, another idea emerged, an idea as old as our fascination with the stars, and as bold as any we've dared to dream. What if the dips in light were not caused by dust or ice or natural debris? What if they were caused by something built? This was the seed of the so-called alien megastructure hypothesis. It was not scientists who first shouted it to the rooftops, but rather a journalist writing about the mystery for a wider audience. The suggestion appeared almost as an aside, that one possibility, however remote, was that the strange dimming of Tabby's star could be the signature of vast structures, machines orbiting the star, harvesting its energy, obscuring its light. The idea took hold quickly because it was both astonishing and simple. If advanced civilizations existed, might they not seek to gather energy on scales beyond our imagining? Our own species has filled landscapes with solar panels, built towers of steel and webs of wires. Scale that ambition upward, across centuries or millennia, and perhaps one might attempt to capture a star itself, enclosing it in swarms of collectors, known in speculation as a Dyson swarm. Such structures would dim the star's light in ways irregular, deep, and strange, much like what we were seeing in Tabby's star. For a brief moment, the world let itself imagine this possibility. Headlines spoke of the alien megastructure star. Articles painted pictures of vast solar panels drifting across stellar faces, civilizations so advanced they could reshape their suns. Social media buzzed, mixing awe with skepticism, curiosity with humor. It was the kind of story that spread not only because it might be true, but because it was beautiful to imagine. And yet, for the scientists closest to the mystery, caution remained. Tabetha Boyajian herself, whose name the star carries, stressed again and again that natural explanations must come first. Extraordinary claims require extraordinary evidence, and the evidence, while puzzling, was not enough. Still, the idea lingered, not as conclusion but as possibility, a ghost of wonder trailing behind the data. There is something comforting about this moment in the story, not because aliens were found, when they weren't, but because the hypothesis reveals how open our imaginations still are. Even in an age of data and skepticism, the mystery of a flickering star can still awaken childlike questions. Could someone be out there? Could they be building, watching, shining back at us across the light years? Astronomers took the idea seriously enough to test. If a civilization were harvesting starlight, there might be waste heat, infrared radiation spilling outward from vast machinery. Telescopes searched for such excess heat around Tabby's star. None was found. If megastructures were there, they did not glow as expected. Other possibilities were examined, but the evidence leaned back toward dust, toward comets, toward natural explanations cloaked in complexity. Still, the idea did not die. It lives on not because the data supports it, but because the imagination needs it. For centuries, we have wondered if we are alone. Tabby's star, for a fleeting moment, gave us permission to imagine a sign, a beacon, a clue. Even if the truth is more mundane, the dream itself has value. Imagine lying under the stars tonight, eyes heavy, thoughts drifting. You see a flickering light, one among thousands, and you wonder, what if someone is there, building great arcs of steel and glass, their lives unfolding beneath the glow of a sun half-veiled by machines? The thought is soothing, not frightening, because it connects us to something larger. It reminds us that our curiosity is shared, that across the galaxy, others might also look upward and dream. The alien megastructure hypothesis may be unlikely, but it is not foolish. It is a reminder that science and imagination are partners, not enemies. Science asks for evidence, imagination provides the questions. Together, they stretch us beyond the familiar, into the realm of wonder. And perhaps that is the true gift of Tabby's star, not that it revealed aliens, it almost certainly did not, but that it reminded us to keep the door open, to admit that we do not know everything, that the universe is vast, that possibility still flickers in the dark. As you drift deeper into rest, let this thought be your lullaby. The cosmos is stranger than we can imagine, and yet it invites imagination. Tabby's star flickered, and for a moment humanity remembered that it is allowed to dream. But Tabby's star was not only a story of theories in labs and observatories, it was also a story of people, thousands of volunteers around the world, ordinary eyes helping to sift through extraordinary data. In the next part of our journey, we'll explore the role of these citizen scientists and how the mystery of one flickering star became a shared adventure. Science often carries the image of white coats and laboratories, vast observatories perched on mountains, or spacecraft drifting through the silence of space. But the truth is gentler, more human. Many discoveries begin not in isolation but in community, through countless eyes, patient minds, and the curiosity of people who may never call themselves professionals. Tabby's star is one of those stories. The Kepler Space Telescope gathered mountains of data. It watched over 150,000 stars, recording their brightness day after day, year after year. Each star's light curve became a long thread, waiting to be examined for the tiny dips that signal planets passing by. But Kepler's treasure was too vast for astronomers alone. The human eye, trained by evolution to notice patterns, could sometimes see what machines overlooked. And so, a project was born, Planet Hunters, an invitation for anyone, anywhere, to join the search. Volunteers logged on from living rooms, classrooms, libraries. They scrolled through graphs of brightness, looking for the telltale regular dips of planets. To most, it was a pastime, a way to contribute to the great adventure of discovery. To science, it was an army of eyes, sifting through the sky with patience no machine could match. And it was here, among these citizen scientists, that Tabby's star first raised its eyebrow. Several volunteers flagged its light curve as unusual. Instead of neat, repeated dips, they saw jagged plunges, irregular and deep. Something about the graph felt wrong, strange, worth a second look. They passed their observations to the astronomers leading the project, who in turn handed them to Tabetha Boyajian, and from that moment the story of Tabby's star shifted from data to mystery. Imagine the scene, someone at home, perhaps late at night, scrolling through Kepler graphs on a laptop. They are not a professional astronomer, not trained in spectroscopy or astrophysics. They are simply curious, patient, willing to look. Their eye catches something odd, a dip too deep, a flicker too sharp. They click a box, leave a note, pass it on. And in that small act, history changes. This is the quiet power of citizen science. It democratizes wonder. The sky belongs not to specialists alone, but to all of us, and projects like Planet Hunters give us a way to share in the work of discovery. Tabby's star is a testament to that truth. Tabby herself has often said that without the volunteers, the star might have gone unnoticed. The professional pipeline of data analysis was designed to find planets, not anomalies. It was the curiosity of ordinary people that brought the mystery to light. In this sense, Tabby's star does not belong only to astronomers. It belongs to everyone who paused, who wondered, who clicked. There is something profoundly soothing in this idea, that even in the age of space telescopes and supercomputers, science still needs human attention. That mystery is not reserved for the elite, but open to anyone willing to look. That discovery can happen not only on mountaintops, but in the quiet of a kitchen table, the glow of a laptop screen. As you rest tonight, let that image comfort you. Thousands of people around the world connected by curiosity scrolling through starlight together. A tapestry of eyes, catching patterns in the dark, sharing in the adventure of discovery. Their collective attention turned a forgotten light curve into one of the most puzzling mysteries of modern astronomy. And it was not only the initial discovery. Citizen scientists remained part of the story. When the paper on Tabby's star was published, interest spread. Amateur astronomers turned their own telescopes toward the star, monitoring its brightness, reporting back. Professional observatories joined them, but the community remained broad. People across continents followed the dips, eager to see what would happen next. In this way, Tabby's star became a global project, not just a scientific mystery, but a shared narrative. It blurred the line between professional and amateur, between expert and enthusiast. The star dimmed, and humanity dimmed with it, watching together, wondering together. Perhaps this is the deeper lesson of the story, that science is not only about answers, but about community. That when we look upward, we do so not as individuals, but as participants in something vast and collective. The sky has always been shared. The ancients who mapped constellations were not scientists in our sense, but dreamers, citizens of their own night. Planet Hunters was simply a continuation of that lineage, a reminder that the stars belong to all who watch them. Imagine again that faint light curve. Picture it passed from one screen to another, noticed by eyes across the world. In those dips and plunges, there is not only a mystery of dust or comets or broken worlds. There is also the story of human connection, of strangers linked by curiosity, building meaning together. And so, as you drift towards sleep, let this thought ease your mind. You are part of that community too. Every time you look up at the night sky, every time you let wonder fill you, you join the same lineage. Tabby's star belongs not only to astronomers, not only to data, but to everyone who dreams beneath its light. But the mystery did not fade. In fact, the more people watched, the stranger it became. For Tabby's star did not simply flicker once and stop. It dimmed again, and again, sometimes for days, sometimes for months, as though performing an unpredictable dance. In the next part of our journey, we will follow those longer dimmings and the deeper questions they stirred. When the first Kepler data revealed the strange dips of Tabby's star, many assumed it might be a one-time puzzle, a passing swarm, a fleeting veil, an odd event that would fade with time. But the star had other plans. Its story did not end with Kepler, it only deepened. In the years that followed, as amateur astronomers, professionals, and whole networks of observatories kept their eyes fixed on KIC 8462852, the star began to show new behaviors. Not just sudden dips, but longer fades, stretches of dimming that lasted weeks or even months. These were subtler than the sharp plunges Kepler had caught, but they carried their own weight of mystery. Slowly, the star's brightness seemed to sag, like a lantern flickering low, then recover again. The most startling realization came when researchers compared old photographic plates, images of the sky taken decades earlier, long before Kepler's launch. In those records, Tabby's star appeared brighter. Over the course of nearly a century, it seemed, the star had faded by more than 10%, not just brief flickers, but a slow, long-term dimming. This was baffling. Stars do not simply fade on human timescales. A sun-like star should shine steadily for billions of years. A century is nothing to such a star, like a heartbeat in a human life. Yet here was evidence that Tabby's star had dimmed across just a few generations of observers. What could cause such behavior? The questions multiplied. Was the long-term fade connected to the shorter dips? Were we seeing a single phenomenon, or several layered together? If dust was involved, how could it remain so persistent? If collisions had occurred, could the debris really last for decades? If comets were the culprits, how could they arrange themselves to produce such a prolonged veil? The more the star was watched, the more confusing it became. Between 2015 and 2017, ground-based observatories caught new dimming events in real time. These were smaller than the great dips Kepler had seen, but they carried the same irregular fingerprint. Astronomers scrambled to gather spectra during the dips, hoping to catch the composition of whatever was blocking the light. They found some hints, slight changes that suggested dust, but nothing decisive, nothing that could close the case. It was as if Tabby's star were performing on a stage, teasing us with glimpses, never showing the whole play. Each act revealed enough to provoke theories, but not enough to prove them. The star remained stubborn, unyielding, mysterious. For the scientists, this was both thrilling and humbling. Thrilling, because here was a star that defied expectations, demanding attention, pulling telescopes from around the world into its orbit of curiosity. Humbling, because despite all our tools, all our models, the star kept its secrets close. It was a reminder that the universe is not obliged to explain itself quickly. For the public, the mystery deepened fascination. News articles spoke of the star that refused to behave, the star that dimmed and brightened like a faulty bulb. Some continued to whisper of alien megastructures, others favoured swarms of comets or veils of dust. But beneath the speculation was a deeper truth. We were witnessing something unprecedented. A sun-like star, steady for billions of years, had chosen this moment, our moment, to flicker and fade. Imagine, for a moment, watching the star night after night. Through a telescope, it is just a pinpoint, no different from its neighbours. Yet in the data, it tells a story. One night, its light seems just a little weaker. Weeks later, weaker still. Then, slowly, it recovers. To the eye, it is imperceptible. To the instruments, it is undeniable. Like the tide ebbing and flowing, but without rhythm, without predictability. There is something almost alive in this irregularity. Not alive in the biological sense, but alive in the way it resists pattern, resists prediction. The star becomes less like a machine, more like a presence, enigmatic, inscrutable, hinting at complexity beyond our grasp. For those of us drifting towards sleep, there is comfort in this, because it reminds us that even the steadiest things, the stars themselves, can surprise us. That certainty is never final, that the cosmos still has corners of mystery. Tabby's star flickers, and in that flicker, we are reminded of wonder. Some researchers began to suspect that perhaps the dips and the fades were caused not by structures near the star, but by material between us and it, vast clouds of interstellar dust drifting through space. Perhaps we were not watching the star itself change, but watching a cosmic curtain pass slowly across our line of sight. Yet even this theory stumbled, for the details did not quite fit. The dimming was too deep, too irregular, too strange. And so the questions grew deeper, not shallower. Longer dims brought longer uncertainties. Instead of solving the puzzle, each new observation seemed to stretch it further, like a riddle that becomes harder the more clues you gather. But perhaps that is the essence of discovery, not in answers, but in deeper questions. Tabby's star reminded us that science is not a straight line from puzzle to solution, but a spiral, circling closer, sometimes drifting outward, always fueled by curiosity. As you rest tonight, let that spiral soothe you. Imagine the star, 1,500 light-years away, glowing faintly, sometimes strong, sometimes weak. Imagine the graphs of its light, lines dipping, rising, sagging again. Picture the astronomers comparing old photographs, seeing the slow fade across decades. Feel the weight of their wonder, the humility of their questions. And then let yourself drift into the thought that not all mysteries must be solved to be meaningful. Sometimes it is enough to watch, to wonder, to be reminded that the universe is still larger than our categories. Tabby's star flickers, and in its flicker, we find peace. And yet, slowly, evidence began to point in one direction. Subtle changes in the star's spectrum hinted at dust, real dust, not imagination, not theory. Dust that dimmed some colors more than others, dust that could account for at least part of the mystery. In the next part of our journey, we will follow those clues, how dust stepped back into the story, and why even then, the enigma of Tabby's star remained unresolved. For years, the story of Tabby's star drifted between possibilities. Comets, collisions, alien megastructures, all rose and fell as candidates. Yet beneath the swirl of ideas, one quiet suspect remained: dust. Fragile, weightless, abundant. Dust has long been the universe's veil, softening light, scattering colors, dimming brilliance. It seemed too simple, almost mundane, to explain so unusual a star. And yet, as observations deepened, the trail of evidence began to lead back toward it. In 2017, new monitoring campaigns watched carefully as Tabby's star dimmed again, this time in real time with telescopes ready. Unlike Kepler's distant gaze, these instruments could split the light into its spectrum, measuring not only how much light was lost, but which colors. If dust was involved, the signature would be clear. Shorter wavelengths, the blues, would fade more strongly than the reds. If a solid object were blocking the light, a planet, a megastructure, the dimming would be uniform across all colors. And there it was. During one of the dips, the star's light dimmed unevenly. Blue faded more than red. The fingerprint of dust was imprinted on the starlight, faint but undeniable. For the first time, there was direct evidence that dust was playing a role. It was a moment of revelation, and also of humility. After years of speculation, the culprit seemed not exotic but ordinary. Not machines, not shattered worlds, but particles, tiny grains drifting between us and the star, delicate enough to float, numerous enough to veil. But science is rarely so tidy. Dust could explain much, but not everything. Yes, it fit the color-dependent dips. Yes, it could account for some irregularity, but questions remained. What kind of dust could persist in such quantities? Where had it come from? Was it orbiting the star, or drifting through interstellar space between us and it? And why then did the long-term fading still seem so unusual, too steady and deep for dust alone? The mystery had shifted, not vanished. Dust was no longer a mere suspect. It was confirmed as a participant. Yet, it was not the whole story. Some astronomers proposed that the dust might come from a fragmented body, a planet or large moon torn apart by the star's gravity, scattering grains into orbit. Others suggested swarms of comets disintegrating, each releasing trails of dust that overlapped and lingered. Still others imagined vast rings of circumstellar material, tilted at angles, drifting slowly into our line of sight. Each scenario produced dust, yes, but each came with its own complications. There was also the puzzle of scale. The dips were too deep, the fades too long. Dust could explain the color dependence, but could it really block 20% of a star's light without leaving other signatures? Could such a cloud exist without glowing brightly in infrared, as warmed grains usually do? Observations showed only faint warmth, too little to match the depth of the dimmings. Once again, answers slipped into questions. And so, the star continued to resist full explanation. Dust had entered the stage, but the play was not over. For those watching, there was a mixture of relief and disappointment. Relief, because dust was at least something tangible, a natural cause that could be studied and modelled. Disappointment, because the more exotic possibilities, broken planets, megastructures, were fading into improbability. The mystery was becoming quieter, less sensational. Yet it was still unresolved, still strange, still unique. There is beauty in this kind of resolution in progress. The truth was not as dramatic as headlines once suggested, but it was also not as simple as a closed case. Tabby's star remained enigmatic, still dimming, still puzzling. Dust explained, but did not explain away. Imagine, for a moment, the star itself. From its surface, blazing with nuclear fire, light streams outward in steady radiance. Across the gulf of space, grains of dust drift like motes in a beam of sunlight, scattering, absorbing, tinting. From our vantage point, those tiny grains loom large, casting veils across centuries of light, making a star 1,500 light-years away flicker like a candle. Something so small, altering something so immense. There is a kind of poetry in that. Dust is fragile, easily disturbed, easily destroyed, and yet, in great numbers, it can change how we see the universe. Tabby's star is a reminder that sometimes the profound comes not from the massive but from the minuscule. For you, lying in rest tonight, this story carries its own comfort. We search for grand explanations, but often the truth is gentle. Not alien machines, but dust. Not cataclysms, but quiet veils. The universe, in all its vastness, can still be shaped by the smallest of things. And yet, let us not forget, the mystery remains. Dust explains much, but not all. There are still dips too deep, fades too long, puzzles unresolved. Tabby's star is still, in its way, a riddle, and perhaps that is why it continues to enchant us, not because we expect an answer, but because it continues to resist one. Science moves forward by refining mystery, not always resolving it. Tabby's star has been refined, its mystery gentled, its edges softened. But it still glows in our imagination, a reminder that the sky has not finished surprising us. As you drift deeper into sleep, let that thought cradle you. The answers we seek may turn out smaller, softer, subtler than we expect. Dust is ordinary, but in Tabby's star, it becomes extraordinary, and perhaps that is the greatest lesson. Even the smallest things can change how we see the universe. But Tabby's star is more than a puzzle of dust and dips. It is also a mirror, showing us what science itself is, tentative, patient, humble in the face of mystery. In the next part of our journey, we'll step back from the data and reflect on what Tabby's star teaches us about the practice of science itself, about curiosity, doubt, and the courage to admit we do not yet know. Every mystery in the sky is, in the end, also a mirror. The way we respond to it reveals not only what we know about the universe, but also how we practice the craft of science itself. Tabby's star, with its flickering light and stubborn secrets, has been such a mirror. It has shown us not just the limits of our knowledge, but the very spirit of inquiry. From the beginning, astronomers did what they always do. They began with the ordinary. They tested the familiar patterns of planets, dust, comets, collisions. They compared the data to models, searched for signatures, weighed probabilities. Each idea was entertained, tested, found partial, sometimes wanting. And through it all, they held fast to the most important phrase in science: we don't know yet. This simple phrase is more powerful than it seems. In a world eager for certainty, science makes room for humility. It acknowledges the unknown not as failure, but as the natural state of learning. Tabby's star became famous not because we solved it, but because we admitted we could not, at least not yet. That admission, honest and unpolished, carried weight. It revealed science not as a factory of answers, but as a journey of questions. There is something profoundly human in that humility. We want the universe to be neat, to present itself in tidy patterns, to yield its secrets quickly. But Tabby's star reminded us that discovery is slow, that wonder often lives in uncertainty. It reminded us that science is less about final answers and more about careful listening, about waiting, watching, revising, doubting, and trying again. For Tabetha Boyajian and her colleagues, this was a lesson lived daily. To publish a paper that said, in essence, here is something strange, and we don't know why, required courage. It meant exposing mystery, not mastery. It meant inviting others to puzzle alongside them, to critique, to speculate, to imagine. And in that invitation, the process of science was laid bare, collaborative, uncertain, open. Citizen scientists, too, became part of this reflection. Their role in noticing the strange light curve showed that science is not closed to outsiders, but enriched by many eyes. The universe is too vast for any one group to explore alone. In Tabby's star, we saw how distributed curiosity could bring forth something extraordinary. Science is strongest when it is shared. The star also reminded us of the balance between imagination and restraint. On one side, the allure of alien megastructures captured headlines, sparking excitement far beyond the scientific community. On the other, astronomers gently pulled the narrative back toward dust, comets, the broken worlds. Both sides played their part. The wild hypothesis fed public wonder. The cautious testing kept us grounded. Science needs both, the dream and the discipline, the spark of what if and the anchor of evidence. Perhaps the greatest lesson of Tabby's star is that not knowing is itself valuable. In a time when data pours from every telescope, when algorithms churn through signals, it is tempting to believe that mysteries are fading. And yet, here was a star that defied us, that reminded us of the frontier still present even in the most ordinary-seeming patch of sky. To admit we don't know is not weakness, it is the first step toward deeper discovery. Imagine, for a moment, the astronomers gathered around data from the latest dimming event. Graphs spread on screens, spectra analyzed, models debated. One person suggests dust, another comets, another interstellar clouds. No one is certain. The room hums not with answers, but with questions. This is the sound of science at its best, not the silence of certainty, but the music of curiosity. For you, resting now, perhaps this lesson can ease the weight of unanswered questions in your own life. To not know is not always to be lost. Sometimes it is simply to be present in a process, waiting, watching, listening until clarity comes. Tabby's star shows us that uncertainty can be beautiful, even fruitful. There is also patience in this lesson. Stars live for billions of years. Our observations span only decades. Perhaps the pattern of Tabby's star is long, unfolding on timescales we cannot yet perceive. To study it requires patience, not only of years, but of generations. Science is not only about what one lifetime can uncover, but what many lifetimes can build together. And so, Tabby's star teaches us to be patient with mystery, to value the process over the prize, to cherish the questions, even when answers are far. It teaches us that science is not about conquering the unknown, but about living with it, step by step, with humility and care. As your body grows heavy and your mind drifts, let this truth soothe you, that the unknown is not an enemy, but a companion, that to not know is not to fail, but to journey. That the flickering of a distant star can remind us of the flickering of our own curiosity, fragile but enduring, soft but steady, guiding us ever onward. Tabby's star has not yet given up all its secrets. Perhaps one day With new instruments, we will know more. Perhaps we will discover the dust in greater detail, or catch the fragments of a broken world, or trace the clouds drifting across light years, or perhaps it will remain a riddle, a story half told. Either way, it has already taught us what matters, that science is not about the stars alone, but about how we meet them, with humility, with imagination, with patience, with wonder. But every story must find its rest. Tabby's star, with its puzzling dips and its lessons of wonder, eventually fades into the background of the sky, just another point of light among thousands. In the final part of our journey, we'll offer a gentle farewell, a reflection on mystery itself, and a quiet good night beneath the flickering stars. Every story in the night sky, no matter how bright or strange, eventually softens into silence. The brightest comets fade, the most dazzling novas cool, and even mysteries like Tabby's star return to the quiet rhythm of ordinary starlight. Their stories linger, but their flickers ease back into the tapestry of the heavens, where countless other lights shine steadily. So it has been with Tabby's star. For all its commotion, for the years of speculation, the countless papers, the headlines that called it the most mysterious star in the galaxy, the star itself has carried on without notice. To anyone gazing up with the naked eye, it appears no different than its neighbours, a faint glimmer in the constellation of Cygnus. The drama is invisible to us, tucked within careful graphs, long-term monitoring and sensitive instruments. And yet, that is the quiet truth of astronomy. Much of the universe whispers. Its greatest stories are often hidden not in explosions but in subtle flickers, not in spectacle but in persistence. Tabby's star has taught us this, that even a faint dimming, barely perceptible across light years, can stir our collective imagination. The star continues to be watched, of course. Telescopes still point toward it, still measure its brightness, still search for clues. Dust remains the strongest explanation, a veil of fine grains drifting, scattering light in complex ways. Yet even with dust acknowledged, questions linger. Why this star? Why such deep, irregular dips? Why such long-term fading? The answers are not yet complete, and perhaps they never will be. But perhaps the answers are not the point. Perhaps the point is the mystery itself. For what Tabby's star has given us is not certainty, but wonder. It reminded us that the universe is still full of surprises. It reminded us that science is not about being finished, but about being open. And it reminded us that even something as small as a flicker in the dark can bring people together across the world. Professionals, amateurs, dreamers, all linked by curiosity. As we let this story settle tonight, think of the star as it is now, far away, steady to the eye, yet still carrying its irregular heartbeat. Think of the light leaving it, travelling across 1,500 years to reach us, carrying within it the faint signatures of dust, the hints of something more. That light is already ancient, older than our cities, older than our stories, older even than our histories, and yet, here it is, entering your imagination tonight, a gift across centuries. There is something deeply soothing in this, to know that the universe continues without us, steadily, patiently, flickering and shining in its own rhythms. We are here only for a moment, but in that moment we can witness, we can wonder, we can reflect. That is enough. So, let Tabby's star become not just an anomaly in astronomy, but a symbol in your thoughts, a symbol that even the most ordinary seeming things can hold extraordinary mysteries. A symbol that the smallest flicker can awaken the deepest wonder. A symbol that the universe is not exhausted but alive with questions. And as your breath slows, let the image of that flickering star cradle you. Picture it in the sky, faint but persistent, winking as though it knows something we do not. Picture the dust drifting across its face, scattering light like motes in a golden beam. Picture astronomers watching patiently, notebooks open, instruments humming. And picture yourself among them, not with graphs or telescopes, but with wonder in your heart, sharing in the mystery. Because that, in the end, is what binds us all. Not the answers, but the questions. Not the certainty, but the wonder. Tabby's star flickered, and the world paused to notice. That pause is enough. And now, dear dreamer, our journey with Tabby's star comes to its end. We have followed its light from the steady gaze of Kepler, through the curiosity of citizen scientists, through theories of dust and comets, through whispers of alien megastructures, and into the deeper reflections of science and wonder. We have seen how one star's flicker can ripple outward, stirring questions across the Earth. Tonight, let that story lull you. Let it remind you that mystery is not to be feared but cherished, that the unknown is part of what makes the universe so comforting. The sky above is not only filled with stars, it is filled with questions, and with the gentle reminder that curiosity is a kind of light in itself. So rest now, close your eyes, let the flicker fade into stillness, let the mystery soften into sleep. The stars will keep shining, the questions will remain, and tomorrow you may wake to wonder again. For now, you need only this: the calm of the night, the comfort of the story, the peace of knowing that even in uncertainty there is beauty. Good night, traveller. Sleep deeply. May your dreams be as vast and mysterious as the stars themselves.